Hey everyone, today what we're going to do is go through a really quick video just going through how to do dimensional analysis. This is something that seems to pop up in a lot of the practice material in section 3 every now and then. I think that if it was to come up, it would come up once, but I know that I got a question on dimensional analysis in March. It looks pretty consistent. People are talking about it a lot, saying they've seen it in the test. So even though it's a relatively small topic, it's a really easy grab for marks if you know how to do it. So we're just going to go through that specific skill. It's not tied down to one of the specific science disciplines. It's just more of a math skill more than anything. Once you understand it, you can kind of extrapolate it to literally any other question. There's just a few formulas that you need to rely on, which we'll kind of point out. All right, so basically, first of all, across the top in black here, I've got these are the key formulas that you would need to know. Sometimes they're given in questions, but in a dimensional analysis question, they very rarely give you the kind of fundamental formulas, so it's worth knowing each of these. So we've got pressure is force divided by area, then you've got force is mass times acceleration, then work energy, so work is an energy itself, is force times displacement. Then you've got velocity is speed over time, we should all be familiar with that one. And then we also have acceleration is distance or displacement over squared time. In other words, change in velocity over change in time. And then Q at the end there is charge. If we're talking about electrical circuits, Q is equal to I times T, so that is current times time. And let's also throw in as well Ohm's law, because that's probably useful. Voltage equals current times resistance, like that. So these are going to be the basic underlying principles that we use. In pink here, these are all of the most common dimensions that we see. Any other obscure ones they will give you in the question. They'll say things like number of mole, for example, might be represented as an actual dimension, so you don't have to go breaking it down any further. The most common though are length, mass, and time. They love those ones. And then the other one that we're throwing in for today's is current. We're going to put that as the letter A as well. So effectively, we just want to manipulate the formula first to solve it for the variable we're interested in finding its dimensions. Then from there, what you're trying to do is re-express each of the variables that it responds to in terms of its basic dimensions and then dumping it all together. And that's pretty much it. So if you look at the first one, we've got technically Newton's law of gravitation here. So what we're going to do is we're going to try and see if we can work out the dimensions of G, which is the gravitational constant, right, by rearranging the formula. So the first thing that we're going to do is just try to get G on its own. So we can times the R squared across. I'll do it in bits, but you could also skip steps if you're comfortable with the maths. Then you can divide the M1 and M2 under here. So force times radius squared over mass 1 times mass 2 should be equal to G. And so then from there, we can see we don't have everything down into all of its dimensions. The masses are good to go. Radius here is really just a length, so that could be L, but force is the problem. So what we're going to do is use that first formula, which was second formula, which was force equals mass times acceleration, right? So we're going to replace this with mass times acceleration. And I like to just do it in terms of the actual mass times acceleration. There we go. I like to just do it in terms of the actual variables in the equation first and not the dimensions. And then I'll get R squared over M1 M2 is equal to G. So then my problem is acceleration doesn't have its own dimension, so we have to break that down. So we use another formula, that's distance over time squared, and both of those are the basic dimensions of length and time. So if I rearrange now or re-express A in terms of displacement over time squared times R squared over M1 M2 is equal to G, now I can put all of my dimensions in, and I'll switch colors here to make this a bit easier to see. So mass is just capital M. Then we've got displacement, which is a length, divided by time squared, so capital T squared, multiplied by R squared. Remember, R is a length, so that is L squared as its dimensions. And then all over mass times mass, so let's just put that together as mass squared. And that should be the dimensions of G. We just have to then clean up the fraction. So from there, we can times across the top here, and then this, because we're dividing it by a whole number, it'll times to the bottom. So we get ML cubed over, and then M squared T squared. And then finally, we can cancel out one of the M's, and we can get L cubed over MT squared. And that would be the dimensions of G, plain and simple. It's really just a maths thing. It's not anything to do with the actual knowledge of the formula all that much, apart from recognizing what variables you're dealing with. So let's just practice it and prove that it keeps working. So say we had this one here, so electrical energy is voltage times current times time, and we're interested in working out the dimensions of the voltage. So the first thing is, let's rearrange it for voltage. We would divide the I and the T underneath like this, and then we'd work out what are we dealing with. So we've got energy, right, which is not on its own one of the key standard dimensions. So we can go over here. Even though it's work is just a measure of energy. We use that formula quite loosely. And so we can replace energy with F times S. So force times displacement over current times time. Now the denominator is okay because that's made of two basic dimensions. I don't have to change those. Then we've got force coming up again. So we know force is mass times area. So MAS over IT. And we get that same thing again, where acceleration needs to be converted. That is displacement over time squared times S over IT. We'll come out here, we'll clean that up. So that is ms squared over IT cubed, like that. And then we can now turn it into its dimensions. So that is mass times displacement or length squared over current, which we were calling A in this one. And then t cubed time squared, time cubed. It's t cubed like that. There's nothing really to cancel out in this particular case. So this becomes the dimensions of voltage. And then finally, we've got Ohm's law written up. So how do we get the dimensions of R? So what I'm going to do here is just use my knowledge of what V already is, right? This was V. So if I just rearrange this for R, I get V on I. I can replace, let's go straight for dimensions. Then we get ML squared over AT cubed, all divided by current, which is also A, like that. And so then we get ML squared over A squared, and then T cubed, just like that. And these are all the basic dimensions. That would be the dimensions of resistance. Done. So there we go. So you can see that you can literally just rearrange, then re-express any of the formulas that don't have their basic dimension, or any of the variables that don't have a basic dimension. Then from there, dump all your dimensions in, and then clean up the fraction, or whatever it is that you're dealing with in the maths, and then cancel anything out, and then you should get a simplified dimensional analysis. Simple as that. Try that in the ACER questions, try that in other practice questions. You can also just kind of pick random formulas. You just Google like random physics formulas and stuff and see if you can break it down through the dimensions using these formulas. Sometimes you might get other ones that rely on other things that don't have their own basic dimension and it would have to be given. But maybe even if you sift through the ACER stuff, just look at the formulas that are given. Don't actually use the formula for the question, just take it for dimensional analysis, practice it, and then you can always just Google, dimensions of that variable, and then you should be able to pull up a result that actually shows you what it is. You can check your answer. Cool. Easy. Hopefully that was helpful, nice and short and sweet. And yeah, we're coming up to the end of the week now, so I'm trying to get as many videos as I can out this week before I take a short break. So I'm hoping to get another sample section 3 video out, but I don't know whether or not I'm going to get time to get it done because I've got a lot of other stuff scheduled between now and the weekend. But I will see. If not, then I'll have it carry over to the new year. But as always, I will see you guys in the next one.